All right, so you go to geogebra.org. All right, if you're following along with me right now, you can go geogebra.org, and I like to use the GeoGebra Classic. I haven't used these quite yet right now, but GeoGebra Classic works fine. So there is a download, so there is an app that you can use for tablet or cell phone. I'm not quite exactly sure how good that app is. Some people say they have trouble with it. So online, it's pretty good online. So you're going to need this for your homework, and you're going to need this for the lab if you do the lab early before you come on Friday. So we're going to hit Classic here, and it's going to load. This is the part of the video where you go at double speed. What? Of course I lose my internet connection. And we're back. Okay. So you're going to get a screen that looks like this. Now we want a screen where we can enter in data. So right here, this 3 bar up here, we're going to click on that 3 bar. And we're going to click on this little thing right there. And then we're going to click on this 3 dot guy here. All right. And that 3 dot is going to give us some options. And we're going to use a spreadsheet. A spreadsheet will allow us to enter in data. So we're going to click on this spreadsheet and we're going to have data. Now I like just to move this over a bit. I'm not going to need that, that graph there. And right in column A is where I'm going to enter in my data that I have for, I guess, dominoes in this case. So I'll go back. And using this problem here that we have, I don't know if I can, it won't let me do that one. So I will collect it from here. So you'll have to type them in. I have, I can do this quicker here and just put them in like this. So this is my dominoes column. I want them all in that column. So I'll give you a second to add those in. I'll put in the other one too before I go on to the next step. Where was I? Here. So next what we're going to do is you're going to click on and highlight both of those columns. Try your best to do that. I know some of you with the track pads are not easy. You're going to click and highlight both of these, and you're going to click on this histogram that's over here to the left. And when you click on that histogram, you'll have 1 variable analysis, 2 variable analysis, multiple variable analysis. Okay, we're going to click on multiple variable analysis. And that will give us 2 stacked bar charts. Not bar charts, box plots. Why did I say bar charts? It'll give us 2 box plots, which is great. We're going to need these box plots later. We could also, if we wanted to, go back and just do one of these. And we can see the histogram. All right, so if we just wanted one of them, we can see the histogram. We can scale the histogram if we want. This is nice because in our t-test, we need to know that the histogram is fairly unimodal and symmetric. Now, I would recommend that with these data, these are discrete data, you would just want to do a dot plot, which is what I'm going to do when I do my conditions in just a second. But I want to show you how to do the confidence interval and the t-test in here. So I'm going to go back to doing my multiple variable analysis. And I'm going to click on this little summation X. If I just hover over it, it says show statistics. So I'll click on that. And then down here on the bottom is where we're looking. So down there on the bottom, column A is my dominoes column. I have a mean X bar of 6.75. S of 2.22, and it gives me my 5-number summary. Down here, column B, this is my my PJ, and it gives me my summary statistics here. So I'm going to need those to plug in my formulas. Are we okay? Yes? Okay. I haven't done actually the inference yet. Let me show that to you now. This is the part that's going to be important. So right here where it says stacked box plots, actually right here where it says statistics, I'm going to click the drop down on that, and it gives me some options. ANOVA, which we'll do a little later. We have a t-test difference of means, which is what we're using now. We've got matched pairs, which we'll do also on the next class. So estimate, whenever it says estimate, we're looking at a confidence interval. A test is our t-test. So since first we're doing a confidence interval, let's click on estimate. And bada bing, bada boom. We've got what we need. So what we're looking at here is lower limit and upper limit. So I'm just going to do a little magic here. Snip this here. Snip that for me. Control C. Throw it in here so I can see it. It's not letting me go to the next page. It won't let me do it. Okay, so what's we got? 0.182 and 3.984. So I'll write those in here. So my confidence interval for this is going to be, oh, you know what I did? I'm sorry, guys. Totally messed that up. Not totally, just kind of. Just slightly. What's my confidence level? 90. So I have to change this to 90. Click enter and my numbers down here change. So I got 0.5093. 0.5093. And I've got 3.6574. So the most important thing here, because you're using GeoGebra, you're using technology to come up with this, is the interpretation of what that interval means, right? That's where I'm really looking for your work, your knowledge. So it's the interpretation. Let's go ahead and interpret it. We are 90% confident that the true mean taste rating for, okay, we got to look at the first one. What came first? D stood for Domino's. Taste rating for Domino's is between 0.5093 and 3.6574 points higher than the mean taste rating at PJ's. Does that make sense? All right. This is the important part. Side note to my notes. Important note on my notes. In the interval, negative means lower and positive means higher. All right, so that's why I got the word higher here, because they were both positive. If one was negative and the other one was positive, then I would have said we are 90% confident that the true mean taste rating for Domino's is between, if this one was negative, I would have said 0.5093 lower and 3.657 higher. this is the same as what we did before with the two prop z tests, z interval. Yes, did you have a question? You have a question?
Oh, yes.
Oh, okay. Good. Okay. Does that make sense? Yes? Is that hard? Some of you are saying yes. Okay. Let's do B. So B is the actual hypothesis test. So the first step we need is our hypothesis. I know you guys are burning up in here. It's like melting. Our null hypothesis. Well, we want to know if the mean rating here is higher than the mean rating here. So I'm going to write this like this. The null is going to be mu d is equal to mu pj, right? The null hypothesis is always an equal sign. What would be the alternative? Mu d is greater than, right? Mu pj. We're good with that? Not too bad. All right, let's talk about the conditions. All right, the first condition, both samples were taken at random. Yes?
You want to state what mu is first?
Because I used subscript descriptors that are context-based, you don't have to. But not at least not for me. Like I can clearly see that mu d is going to be the mean taste rating of Domino's, and you got PJ. I know what those are. But if you want to make sure, then you can state it here. Mu d is the mean taste rating for Domino's, and mu pj is the mean taste rating for PJ. Just whatever you don't put like the mean taste rating of the customers that were surveyed, right? Because we're talking about population. All right, what's the second one? Independent within samples. Is it safe to assume that each person's rating is independent from another person's rating? As long as maybe they're not married or some sort of matching. I guess we can assume that. So let's go ahead and assume that. Assume each person's rating is independent of another's. Okay, this is the within groups independent condition. And then there's the between groups independent condition. Assume each person only is at one restaurant. Again, ideally, this would be something like a blind taste test. I think that would be a better option for this problem. And then finally, we've got our normality condition. So we have to actually draw the histogram. Now, these data, again, are discrete. So I'm going to want to draw a dot plot. It's easier to do that. Let's draw a dot plot. So let me draw it over here because here's our data. And then we'll just we'll draw an arrow to the fore so we can say, oh, look, here's our dot plot. I'm going to draw an up and down dot plot. You ever see one of those? If not, I'm going to show it to you now. let's use green for dominoes. All right, and then you're just going to go up. 10, 10, 7, 7, 9, 6, 8, 7, 5, 4, 4, 4. And then we'll use orange. So then I'm going to do down 8, 8, 5, 5, 5, 6, 2, 3, 2, 1, 5, and 6. What color? So what do you think? I think this one's it's close enough. Fairly unimodal and symmetric. This one's a little bit better, right? Doesn't have to be perfect, folks. It just has to be kind of enough. Enough that it's not clearly skewed to the right or skewed to the left. So, both distributions are fairly unimodal and symmetric. And I'll point to the histogram up there as proof. All right, so now we're going to do a two-sample t-test, and here comes the fun part. Our mechanics. So here's what I want you to do in your mechanics. All I want is your t-value and your p-value. And all you have to say is p-value. P-value equals. Okay? That's all. That's all I want. You don't have to put anything else. You don't need like a formula. You don't need anything. So you're going to do this in the calculator or in your computer, and then you're going to write those down. So go back to Geogebra. And now right here, we're going to click, instead of t-estimate, we're going to click t-test, difference of means. And like technological magic, P, that must be our p-value, correct. Wow, you guys are on fire again. And T must be our t-score. Yep, that's right, t-score. Okay, so I'm going to write 2.2727. And the p-value was 0.0332. Oh man, you're always messing with me. Yes, we do. It's going to divide this by, it's going to take this score right here, the p, and divide by 2, right? Because since it defaulted to a not equal sign, and we're on a greater than sign, so we want a greater than, and then it just divided by 2. So the t-score doesn't change, but the p-value does. So 0.0166. Thank you. You saved me from making a ginormous mistake on this wonderful video. Okay, now we write our conclusion. What does our p-value tell us? Are we going to fail to reject or reject the null? Was I given an alpha level?
Yes.
0.05. Does that correspond to 90%? Yes, it does. Okay, so 0.05. If our alpha is 0.05, what are we going to do? We're going to reject the null. So, since the p-value of 0.0166 is less than alpha, there is evidence that the mean taste rating for Domino's is greater than the mean taste rating. I know I'm writing fast. For PJs. And there you go. That's our 2-sample t-test. It says it's recording. I can't figure out how to stop it.